Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When a compound bearing both a thioester, Sc, is equal to O, CH3, and an acetate ester, OC, is equal to O, CH3, on adjacent carbons of a bicyclic framework is treated with hydroxide, O, selective hydrolysis and intramolecular cyclization can occur. Moving on to the next step. Identify the stereochemistry of the starting material. The S-acetyl group is on a wedge bond above the plane at 1 carbon and the O-acetyl group is on a dashed bond below the plane at the adjacent carbon. This means S and O are on opposite faces, trans to each other, on the bicyclic ring system. Moving on to the next step. Hydroxide first hydrolyzes the thioester selectively. Thioesters are more reactive toward hydrolysis than oxygen esters under mild basic conditions, generating a thiolate anion, Rs, in situ. Alternatively, the thiolate is liberated and the acetate ester remains momentarily. And for the final step, the thiolate anion, now on one face of the ring, performs an intramolecular backside, SN2, attack on the carbon bearing the acetate, leaving group is equal to acetate, OAC. For an intramolecular SN2 to occur, the nucleophile, S, must approach from the back face relative to the leaving group, OAC. Since S is trans to OAC on the bicyclic system, this backside attack geometry is accessible, leading to inversion at the carbon-bearing OAC. The intramolecular SN2 by the thiolate on the adjacent carbon bearing the acetate displaces acetate and forms a three-membered sulfur-containing ring, episulfide thyrane, bridging the two carbons. This gives a bicyclic compound fused with an episulfide ring. A and B. These show Frisch and OH groups, trans and CIs respectively, which would result from simple hydrolysis of both esters without cyclization. Under the reaction conditions with the trans geometry, intramolecular cyclization is favored over simple double hydrolysis. B. Wrong stereochemistry even for a diol-dithiol product. D. An epoxide would require oxygen to displace, but oxygen is less nucleophilic than sulfur, and the thiolate is a much better nucleophile for SN2 reactions. The thiolate, S, is a far superior nucleophile compared to an alkoxide for SN2, making episulfide formation, option C, strongly preferred over epoxide formation, option D. Therefore, the correct answer is C. Therefore, the correct answer is option C.